In this video, we're going to look at how to find all the zeros of a function using the rational zero theorem. You might remember in the last lesson, we talked about how to use the rational zero theorem to find all the possible rational zeros of a function like this. So what we did was we made a p over q list where p is all the factors of the constant number and q is all the factors of the leading coefficient, and we combined p over q in every possible way. And so we take 1 and put it over each of these denominators, and then we take 2 and put it over each of these denominators, and we have 8 different numbers that might be zeros of this function, but we also have to consider the positive or negative. So we really have 16 different values that could be zeros of this function. But which of these possibilities are actually zeros? The only way to tell is to run the synthetic division with any one of them and find out if it is a zero or not. And we won't have to do all 16. Actually, if we can just find one number that is a zero, we'll be able to find the others if we need to. So here, I'm going to use synthetic division to find out if 1 is a root or a zero of this function. And when after I do the synthetic division, I see that f of 1 is 24. So no, this is not a zero of this function, because if it were, I'd have a zero here. So let's try another value. Let's just take -1 from our list and run the synthetic division with that. And when I run the synthetic division with -1, I see, yes, -1 is a zero of our function because the remainder is 0. And since -1 is a zero, that tells us that x plus 1 is a factor. Remember from the factor theorem how if we do the division with one number, then x minus that number is a factor. So if we run the division with -1, x plus 1 is a factor. Okay, well now we know that the other factor is 15x squared minus x minus 2. And that's what I have here. So instead of writing the function this way, we can write it in a factored form. And that will allow us to find all the zeros. So here's our function in factored form. X plus 1 is a factor, and this result of our division, 15x squared minus x minus 2, is the other factor. Now we're going to be able to find all the zeros of this function, because a zero is just any value that makes the function equal 0. So after I've factored this trinomial into 5x minus 2 times 3x plus 1, then each of these factors has a value that makes it equal 0, and each of those is a zero of the whole function. So the first factor gives us -1, the second factor gives us positive 2/5, and the next factor gives us -1/3. And those are our zeros. So we're going to look at a couple of other examples and just go through this process a couple more times. In this example, we'll find all the zeros of f of x equals x to the third plus 8x squared plus 11x minus 20. And again, I just want you to think about the fact that the only way we had to solve an equation like this previously was factoring, but our factoring methods will not work on something like this. So the only way that we can get started on a problem like this is if we know one of the roots in advance. And this time they did not give us one of the roots, but that's where the rational zero theorem comes in. So our strategy is going to be make a list of possible rational zeros. That is our p over q list. Use synthetic division to isolate one of the zeros, and we only have to find one. After we find that one, we will use factoring to find any remaining zeros. So here we go. Remember, our P numbers are all the factors of 20. So in this case, 1, 2, 4, 5, 10, and 20. Our Q numbers are going to be all the factors of 1, which are simply 1. Now, every possible rational zero has the form P over Q. So we make a list of all the P over Q combinations. And remember that each of these could be positive or negative. So here is actually a list of 12 different values that might be zeros. I just have to find one using synthetic division. So I just always start at the beginning of the list. And so let's see if 1 is a 0. If we do the synthetic division with 1, then we see yes, the remainder is 0. Therefore, 1 is a 0 of this function. Therefore, x minus 1 is a factor of this function. And if x minus 1 is a factor, then this is the other factor. 1x squared plus 9x plus 20 is our other factor. And this is easily factored into x plus 4 times x plus 5. Now, a 0 of the function is anything that makes the function equal 0. We already know 1 makes the function equal 0. The remaining zeros will also make these two factors equal 0. So if x plus 4 equals 0, then x equals negative 4. And if x plus 5 equals 0, then x equals negative 5. And those are our three zeros. They are basically solutions of the equation this equals 0. That's all there is to it. Let's see it one more time. This time we'll find all the zeros of f of x equals 3x to the third minus 7x squared minus 75x plus 175. So we know the strategy now. We have to use the P over Q list to find a list of possible rational zeros. Here are all my P numbers, all the factors of 175. The way I found these was I knew 5 would go into this number, so I did 5 divided by 175, or 5 divided into 175, and I found out that 175 is 5 times 35. Well, I knew that 35 could be broken down into 7 times 5, so that helped me know that 7 times 25 would also equal 175. And so I have 3 sets of factors here, 1 times 175, 5 times 35, and 7 times 25. Now let's get our Q numbers. All the factors of 3 are 1 and 3. Thank goodness that's a shorter list. But now our P over Q list is going to be a little long. I've got to do each of these numbers over 1 and then each of these numbers over 3. And then I have to put a plus or minus in front of each one. And that is a pretty long list. And I really wouldn't want to have to spend all day doing the synthetic division on all of these. But remember, we only have to find one. And usually we can find it pretty quickly if we start at the beginning of the list, because they wrote these problems to be not that difficult. So our roots or zeros that we find are going to be relatively small. I wouldn't worry about the fractions. You're not going to have to divide by a fraction. So I'm just going to start with 1 and see, I did not finish all of the division with 1 in the box, because once I got here and I did 1 times negative 4 is negative 4, and I added and got negative 79, I got negative 79 here. I could tell that adding that was not going to be 0, so I don't really care what it is. I can already see that it's not going to work, so I stop. Okay, 1 is not a 0. Let's do it with negative 1. And see, again, I can see that this is not going to add up to 0, so I'm going to stop and just cut my losses and go on to the next one. Well, 1 didn't work, negative 1 didn't work. Let's see if 5 works. 5 works. So 5 is a 0. And we know then that x minus 5 is a factor. And the other factor is 3x squared plus 8x minus 35. Okay, now the question becomes, can we factor this? And yes, we can. 3x squared breaks down into 3x times x. The signs in my parentheses will need to be different. And last times last has to be 35, so that'll be 5 times 7. And let's make sure that outer plus inner is going to do right. 3x times 5 makes 15x. Negative 7 times x makes negative 7x. 15x minus 7x makes 8x. So these are the three factors for our function, and each factor is going to give us a solution. If x minus 5 equals 0, that tells us x equals 5. If 3x minus 7 equals 0, then 3x equals 7 and x equals 7/3. If x plus 5 equals 0, then x equals negative 5. So our three solutions, or our three zeros, are 5, 7/3, and negative 5. And that's all.